Part 2, we are going to start to talk about how to evaluate some of these limits. And in this part, we're specifically going to focus on graphs and tables, and also introduce the concept of a one-sided limit. So first, we're going to talk about how to actually figure out what the limit is for both a graph and a table. We kind of already did the graph in part 1, but we're going to kind of take a look at it a little bit more formally here in this particular section. So on a graph, you want to be looking at the behavior of the function for what's going on for that particular x value. So here under task number 1, if you take a look here, we're taking a look at the limit as x approaches -2 of the function f of x. So this is our function f of x over here. We're going to take a look by starting at x equals -2, the specific x value that they gave us. And what I'm going to take a look at is what does the function do as we get closer to -2. So from the left, the function is kind of approaching this hole. And from the right, the function is approaching that same hole, which has a y value of 1. So overall, the limit as x approaches -2 of f of x would have a value of 1. Now the next expression is asking you to find the actual value of f of -2. So this means we're going to look at that x-coordinate and its corresponding y-coordinate of one single point. So we're going to go over to -2, and I'm going to go until I actually have a defined point, which is all the way up here, and it has a value of +2. So this is a situation where that point and the limit do not line up. They're actually in different spots. Next is the limit as x approaches 1. So I'm going to go over to x is equal to 1, and I'm going to look at what happens from the function from both sides. So on the left-hand side, it is approaching the hole. On the right-hand side, it is approaching the same hole as we're getting closer to 1. Remember, we're coming in closer to x equals 1. And it looks like we're coming in on that y value of 2. Now, if I wanted to find f of 1, I'd go to x equals 1, and I'm going to scan up and look for points, and I don't see any. I'm going to scan below. I still don't see any points. So for this particular graph, for what we can see, this is undefined. And that's basically what we're going to be doing with graphs when you're trying to evaluate limits, is you're just going to go to that x value, see what the function's doing to get close to that x value and to make sure you're approaching the same kind of area or the same hole, or possibly even the same point. The next thing we're going to do is take a look at some tables. Okay, we're going to use the table feature. Now you can use the Desmos online graphing calculator if you would like. They have a nice table features that's easy to set up, or you can do this in your own graphing calculator to kind of set you up for this, which we're going to show you. So here's my graphing calculator over here, which should be set up very similar to yours. I'm going to show you how you can do a special type of table in this if you don't know how to do this already. I'm going to move myself out of the way. First thing we're going to do is to take a look at the actual function. Now you should recognize this first function from the first part of the video. It was the very first graph that we take a look at. So what I'm going to do is type the function in first. So I'm going to turn my calculator on, go into y equals. You're going to need some parentheses for this one. So we're going to do x cubed, take away 1, and I'm going to divide it by x minus 1. Instead of going to the graph, because I already know what the graph's going to look like, I want to evaluate using the table. Now, if I just go to second table, whatever settings you were last using is what you've got to kind of go off of. And you can see at x equals 1, there is an error, so we don't actually have a point there. But again, we're not really going to trust the point. We want to trust what the patterns are. But if we also look my x values right now for this calculator, it kind of doesn't really get close to x equals 1. I mean, we go to 0 and we have 2, but we're not getting really that close to x equals 1. And these numbers kind of, they start going down and then they turn around and go back up again. So it's kind of hard to predict really where that's going to be. So we want a table that will get closer to a value of x equals 1, and we're going to customize this table. To do that, you're going to need to go into your table settings. So if you have a TI-83 or TI-83 Plus Silver Edition or TI-84, these all kind of fall into the same patterns as how you're going to do this. We're going to hit the second and then hit your window button. And what we're going to do is we're going to change our independent variable to ask. And this just means the calculator is going to ask you what x values you want as opposed to automatically generating them for you. So when you go to ask, we're going to go back to second and table, and you'll see that the table is completely blank. And this is because the calculator hasn't been told which x values you want to try yet. So we want to approach 1. So we're going to try to type in values that are getting closer and closer to 1. So I will start with a tenth away at 0.9. And then I'll do 0.99 to get 1/100th away. And then we'll do 0.999 to get 1,000th away. These are getting much closer to x equals 1, and it makes it much easier to kind of see the trends that they're heading towards. You'll see it goes from 2.7 to 2.9 to 2.99. You can even do even 10,000ths if you wanted, and you get even closer. So it looks like we're heading towards a 3. But we want to check on the other side and to make sure we see what happens on the other side of this. So I'm going to do 1.001, 1.01. Whoa, let's change that. 1.01 and a 1.1. So getting a little bit further away as we go. So starting at 1.1 and kind of working our way backwards, we see that we're also starting to approach a value of 3. So since we're approaching 3 from both kind of underneath the number 1 and also from above the number 1, and we're getting closer and closer to a value of 3, that would let me know that the limit for this will be a 3. Now, if you use the Desmos online graphing calculator, you can just type in whatever x values you want into the program instead of like going through all these setting changes. Now, for this one over here, we've got the limit as x approaches 0 of 1 over x squared. So I'm going to go back into here. I'm going to do 1 divided by x squared. And I'm going to go back into second table. Now, if you look at this from both sides, you're going to see that we have a limit as x approaches 1 of about 1, but we're not really looking for that. We're looking for x approaches 0. So in here, because it's the ask feature, you can go through and clear all of these out one by one if you wanted, or I think you have to use delete. Yeah, and they'll delete them one by one for you, or you can just type right over it. So we're going to start a little bit less than 0. So those would be some of the negative numbers. So we're going to do, say, negative 0.1, negative 0.01. Let's try to get these negative signs in here. Negative 0.001. And then we're going to do a few positive numbers. 1.001. Oh, not 1.001. 0.001. 0.01 and 0.1. Now, remember in your graphing calculator, 1e6 means 1 times 10 to the 6th is what we're talking about here. So that is growing very, very large. We don't have enough spaces for all those zeros, which is why they're using the e there. So as you see, as we get closer and closer to 0 from the negatives, it's going and increasing and becoming larger and larger and larger. From the other side, it is increasing larger and larger and larger. We can probably predict that this is heading towards an infinity. It's heading upwards. So the overall graph of this actually looks something similar to this. That's what's actually happening. So as we're getting closer to 0, the function is heading in a positive infinity direction. So we are going to identify this as being positive infinity. This technically means that this limit does not exist. We are going to use that infinity because it's a lot more descriptive. It kind of tells us why the limit doesn't exist. And the reason it doesn't exist is because as we get closer to 0, the function's heading upwards. The function's going towards infinity and it doesn't stop. So that infinity is really more descriptive than writing does not exist, which is why we're going to use it. So that's how we're going to use our tables to evaluate this. Last one, we have task number 3. I have a small audience member who's watching. Last one is task number 3. We are going to, again, take a look at the graph and kind of talk about what's going on with this graph here. The limit as x approaches -1 of f of x. So again, I'm going to head towards -1, and then I'm going to go up and I'm going to see what happens with the function. So this function from the left approaches that hole. From the right, the function approaches this point up here. So if you notice, the hole is at a level of 2. The point is up here at a level of 4. So the function's not approaching the same value. So this is something where the limit would be undefined, or in the case of Mean Girls, does not exist is also acceptable. And it's not an infinity. They're approaching either a +2 or a +4. It's not approaching infinity. It's just approaching one of those two y values, and it can't agree. The left-hand side and the right-hand side, they don't really match up. They don't agree on which y value we really should be going towards. And that's why it's undefined. F of -1 itself is the filled-in circle at the very top, the filled-in point. It has a value of 4. As we're approaching 1, we'll notice that this pattern heads towards that hole. Again, from the right-hand side, we're heading towards that hole, so that has a value of 2. The actual value itself is going to be 4. That point. So this green situation over here, where we don't have a limit overall because neither one of the two sides kind of agree. One's down at the bottom, one's at the top. It doesn't quite agree with each other. But it does lend itself to the idea, well, there's one of the sides heads towards a y value and the other side heads towards a y value. Isn't there going to be a limit there? And so there's not a limit overall, but there is this idea of a one-sided limit that says, okay, so maybe there's not a limit for the entire domain when we kind of look at this, but we can kind of describe what happens on either side. So if the function on either side doesn't agree, there's technically no limit for that x value. There is, however, going to be a one-sided limit. And this is how we adapt our limit definition to include one-sided. So as we get closer to a specific x value, which we're going to call c, so that's our x value here, we're going to get closer to c but remain less than it. That's happening on the left-hand sides of these graphs when you're under that x value. What we're going to include is this little negative sign after the c. It almost looks like an exponent. So we're going to say as x approaches c, and then that little negative sign means from the left. We're under that x value. We're on the left-hand side. For the right-hand side, again, we're talking about an x value that's c. We're going to have that c down here, and we're going to follow it with a little positive sign in the exponent spot. So as x approaches this number, plus sign means a little bit above that number on the right-hand side of that number. So back up here for task number 3, if we look at this situation where we're undefined with the limit, even though this limit is undefined, we can still write one-sided limits for this. So for the left-hand side that we have here, we're approaching a value of 1, -1. So I'm going to write this as the limit as x approaches -1. And since I'm coming in from the left, I'm going to follow it with a little negative sign right above that. I'm talking about the function f of x, and it approaches a value of 2. Now, if we talk about what happens from the right, the limit as x approaches that -1 x coordinate, but this time from the right-hand side. We're going to use a little plus sign to talk about how the right-hand side, and we're going to say f of x is equal to 4. So again, those are your two limit definitions that kind of talk about your one-sided. So we're going to do one final task that kind of goes through a couple of these examples super quick. If you want a chance to pause the video and try these yourselves, you're welcome to do that first. So as we're approaching 0 from the left, so I'm going to go to 0, I'm going to approach it from the left, and it looks like we're heading towards a y value of 1. As we're approaching 0 from the right, so as we approach 0 from the right, again, it looks like we're heading towards a value of 1. The limit of this function, the limit as x approaches 0 of this function. So this is referring to both the left and the right-hand sides together. Since they're both heading towards 1, we're going to leave that as 1. F of 0 itself, if we look down here, there's the point for f of 0. It's actually just 0. So we're going to do the same thing for x equals 2. So we're approaching x equals 2, and the first one's going to be from the left. So here's x equals 2. We're going to follow the function from the left, and it's approaching a value of 1. As x approaches 2 from the right-hand side, on the right-hand side of 2, we're getting in closer down to negative 1. Now the limit as x approaches 2, and there's no special symbol on there, that talks about what do both of the sides do. Do both sides agree on the same value? And in this case, they don't. Left-hand side is way up high, the right-hand side is way down low, so this one is going to be undefined. F of 2 itself is also undefined since there's no filled in, there's no point for that domain. Check to see how you did, and we'll move on to part 3.